before we get into all that stuff, any questions from homework you guys are working on? So the thing about the homework, remember, is you can turn it in. You can turn in all your homework, chapter 1, 2, 3, on the day of the test. Please don't do that. But you could. And I really couldn't complain too much because I said that's the day that after that day it'll be late, right? Turn it in continuously. People just got it back. Some of them, if it says correct on it, remember that means you got to go correct mistakes. That means you got half credit right now. If you correct your mistakes and get enough of them correct, you'll go up to full credit, right? That'll give you a chance to get to know this stuff really well. You can see exactly where you're having troubles. I put little notes in there to help you study. So it will help you for the test. But I know that life happens, stuff happens. So I want to give you guys until the day of the test so you can kind of manage as things come up, right? Yeah?
For the survey, I really couldn't understand
Oh,
that.
thank you. I try to make this make sense. You mean the little thing at the bottom?
Yeah.
All right, so they made numbers out of little symbols. So I always have people trying to zoom in and trying to figure out what's going on there. So if I had, this is trying to be a 0 maybe, plus, they make symbols to make a plus symbol, and then they have symbols to make a 2. Don't zoom in, zoom out actually. 0 plus 2. So what do you put? You put 2. And it's just really trying to make sure, you guys realize that you can have a program, this is what they call a robot, a program, go in. If this is just pure numbers, it can calculate it, put the number in so it can fill out your survey 1,000,000 times, quick, and skew your data like crazy. Right? And why would people create this type of program?
Time.
Possibly.
Time.
More than that. It does save time, but what are they really trying to do, possibly? Well, submit false information to skew your data and make things look the other way. If you've got something that's going to be on the news, some survey that's being done on somebody's website, you can have your robot attack it, and they'll say, well, it seems that 90% of Americans would like to sink California into the sea. What? No, don't. Thanks. Right, so that's why they did that. But that's just numbers. It's numbers made of little letters, but just look at it as 1 plus 2, and then put 3 in there, and you're verifying I am not a robot. I can tell those are numbers made of little letters. Let me do this survey, right? Is that good? So I think that'll help out maybe the last few of you guys that need to go and do that. Yeah.
Can I ask you a question about 1-3?
Yeah.
In 13 to 20. Wait a second. No, I'm sorry. 21 to, I think it was 32. Where it says to find out if the measurements of nominal, ordinal, interval, or ratio. I kind of had a hard time doing these a little bit. I I understand. I did read, and I went over your notes as well, and I also listened to your video. But I was having a really hard time with this.
Okay, so here's how I would attack a problem like this. So for example, like number 22 is types of movies, and they list drama, comedy. That's automatically not going to be. It's not going to be which 2. Without even thinking about it, which 2 levels could it not be? Interval, ratio. Because interval requires you to be able to do what? Subtract. Ratio requires you to be able to divide. So if I've got named data, qualitative data for the most part, it's not going to be those 2. Then your whole thing is, well, which one of the last 2 is it? Right? So you've already eliminated 2 of your possibilities.
Right.
Then you think, okay, is it just names or is there some kind of order to it? And you could break it down. When they say like voltage measurements, those are true numbers. I could subtract them. I could divide them maybe. And so now you got to think, okay, when I divide them, does the division make sense? Right? So if I took voltage measurements at my house and I was getting like 20 volts and he took it over there for something else and got 40 volts, 40 minus 20 is 20. Does that number make sense?
Yes.
That tells you how much difference there is. Could you also divide it and it makes sense?
Yes.
Because 40 divided by 20 is 2, and that tells me that the one house has twice as much. Cool. So not just can you divide them, but does the division make sense?
Well, you
And
just-
that 2 tells you twice as much. It makes sense.
Okay, so that would be a ratio. Okay.
How about 24?
So real quick, my first step on that kind of problem is break it. You can break it immediately down into, is it one of these two or is it one of these two? And really, if you look at it, you got a 50-50 shot then if you just take a blind guess, right?
But
24, please.
Which one?
24.
24?
yeah.
Oh,
that's
actual
what it was.
temperatures in Fahrenheit. I think I talked about temperatures when we were doing that specifically because temperatures are the weird one. You think that they're real numbers, and they are. You can subtract them, sure. But the division doesn't make a damn bit of sense. I can have a day that is twice as hot as a 0-degree day. I have to be able to have that, right? If it was 0 degrees today, tomorrow it's going to be twice as warm. I've got to be able to, but mathematically, what's twice 0?
0.
So right there, it can't be ratio. 0 doesn't mean what it's supposed to mean. That throws everything off. What's twice as hot as 60 degrees? Not 120 degrees, no. It's more subjective because the scale is screwy. I could say twice as hot as 60, maybe 78, maybe 81. I don't know. It's totally subjective then, right?
That's the one I had.
But mathematically, it doesn't match. So that one is an example of interval. They are numbers, but I can't divide them and have the answer make sense.
It says on page 15 too, there's like a little chart and it says body temperatures.
Cool. Yeah, they have examples, and they give Fahrenheit degree examples, blah, blah, blah. The value of 0 might seem like a starting point, but it's arbitrary. I love it. So that's examples under interval level of measurement. So I think I said that first day, even if you don't read the textbook all the way, at least look at the examples, yeah.
If you're talking about temperature in Kelvin, could you use ratio?
Kelvin is ratio. Because Kelvin measures the amount of energy. So if I have 100 Kelvin and something else has 200 Kelvin, that's twice as much energy in that. Yeah. So Kelvin's great. If you don't know Kelvin, don't worry. You don't need to know Kelvin. Right? He's actually Lord Kelvin. So you'll hear about him if you take some chemistry or physics.
Let me ask you a question. There's no way you can turn on the AC in here.
Yeah, it is kind of warm in here,
It's
isn't it?
extremely.
It's not just me. Maybe can we try to crack both doors open, get a little air through? Can somebody try to crack the door open? Maybe put that. Yeah. Thanks for saying that. I'm always freaking hot, so I never know if it's just me or if it's really warm.
I know it's hot.
Okay. Does
Are
it
you
have-
using calculators today or no? Must be on the password.
Supposedly it's set at 69. I
Do you have any more
tend
calculators?
to doubt that.
That's
No, they're
false.
all out.
That's a
If
false.
you didn't get a calculator, when we get to the calculator part of what we're going to do today, just kind of get with somebody near you that's got one. Kind of look on.
I can go run and grab one. Right? Can you just not talk really fast? Just be really slow. I'll be back in 2 minutes.
No. Just hang out. You can look on with somebody else. It's okay. Any other questions from homework? No. Okay. All right. So just to remind you guys, there are a couple sections in Chapter 1 that do require some interpretation on your part. That's the thing you're not used to in a math class is there's not necessarily one correct answer. It depends on how you're looking at the problem, your interpretation of what's going on, right? In fact, that one section is come up with an alternative conclusion. There's a lot of conclusions that I would accept as valid from the data that they give us. We're not really used to that, but I love stats for that. Stats is the most honest branch of mathematics. It says, hey, we don't know. We're not really sure. It looks like it's this, but we don't know. Okay. So, let's see. Last time we got through section 1.5. We're going to get into actually analyzing data today. Finally, we're going to analyze them. We're going to get away from just straight definitions and get into just pure data. Have you guys ever seen a graph like this? Like if I looked out in some car, in some parking lot, I started seeing how many BMWs are there, how many Hyundais are there, and you can have maybe 10, 20, 30, 40. So then I'd say there, right? You guys have seen this kind of graph before. True? What kind of data is this at the bottom? Just to kind of make a link with chapter 1 here.
Nominal.
Yeah, good. It's qualitative, and even better, it's nominal data. So obviously I can't make a true scale out of it. The way that I put BMW, Hyundai, Ford, did it have to be in that order?
No.
No. So it's not really a true scale down here. If my data is numerical, is quantitative, ordinal or ratio, not order, interval or ratio, then I can make a true scale down here, right? So today we're going to analyze, this is called a bar graph. If the data that you're using is truly numerical, it's called a histogram. So today I'm going to make a histogram with you, and then you guys are going to make your own histogram. I've got a little handout that steps you through what we do up here. Cool. And I think actually the best way to do this is just to slap some data up here. Oh, I can feel that. Feels better. There's some wind coming in. Okay. All right. So, take a second now. Take out your calculator. So if you've got a calculator for me, take that out. Let's take a look at that calculator real quick while that thing is warming up. Because I know some of you guys, anybody have this the first time they're really going to use this bad boy?
Yes.
Okay. So let's do a couple quick preliminary things. And again, I handed out that calculator Bible. That's up on my website if you haven't gotten that yet. The very top of it talks about just purely how do you freaking do 7 plus 8, please to God. Right? So you could type in there, if you start typing 7 plus 8, you see the whole thing. I think most of you guys, even if you didn't have a graphing calculator before, did you have a scientific calculator where you can see the whole problem?
Yes.
Not just the simple one. Did you have the simple one where you hit 7 plus 8 and the 7 went away?
No.
See, that so sucks, doesn't it? Because those calculators suck so much. But this one's kind of nice because you can put the whole thing in there. Which button do you think is going to be most important to us, though? On is good.
Stat.
Like on. Stat, yeah. So assuming we can get it turned on, the most important button is stat. So everybody hit that stat button. Let's see what comes up. Do you see anything that's familiar? Maybe. That you think you know what it does?
Just edit.
Okay, edit. Somewhere I can do something with something.
Yes.
What's the next one below edit?
Sort. 8.
And that, of course, what do you think I could do there? I can put some data in and have it sort my data, right? Which is very useful if I'm trying to count how many, like, 18-year-olds, 19-year-olds, 20-year-olds. If I have it sorted, it's very easy then. Yeah. Oh, the stat button? Yeah. I'm trying to, this thing is taking forever. Yeah, it's right near the top and maybe in the middle. You got it? The stat? Cool. Now everybody hit your edit button. Hit that edit option. You can either hit the 1 or you can scroll down, and hit enter if it's highlighted on the 1. What comes up? How many of you guys have stuff, numbers in the lists? Cool. All right, and the rest of you have, does everybody have L1, L2, L3?
Yes.
Yes? Okay, cool. All right, this guy's finally awake here. Oh yeah. This is you. Use this one? Yeah, I did, didn't I? It took forever. What did you realize? That I wanted to turn on. That one right here. Ah, there you go. Okay. Here we go. If you guys have stuff in that list, don't worry, it's going to come up here. What you can do is, if you hit your up arrow, see how it highlights like list 1? Right, so when you first come in, it should be sitting in that first box in list 1. If you hit the up arrow, it'll highlight L1. Do not hit the delete key, because then list 1 goes bye-bye. You want to clear list 1. So if you hit clear enter, all the numbers should go away. Hey, so if I have like, if I have stuff in this first list, and if I just go up to L1 and hit clear, awesome. Now watch, if I go up to L1 and hit delete, oh shit. Yeah.
I just did that, and except instead it went at the bottom and it did L1 equals.
True, hit clear enter, right?
Yes, I did that.
Beautiful, and now L1 is clear, right?
You know.
You have to go to L1.
Yeah, I did. Oh no, he did it now. Because mine goes at the bottom after I do the clear.
Oh
enter,
yeah.
It goes to the bottom and give me L1 equals blank.
Okay, but now you're good.
Yes.
Okay. Now I've just kind of screwed myself over here a little bit, right? I don't have a list 1 anymore, which kind of sucks. Exactly. So if I go to stat, setup editor. So anytime something freaky is going on, especially for you guys that have to like borrow a calculator from somebody or the library, who knows what the hell the person before you did? You open that bad boy up, it's like, whoa. So if the list is freaky at all, just go to setup editor. And again, basically everything I'm saying today is on that sheet, that calculator Bible that you have with you. Can you use that on a test? No. You should use it on your homework so you get used to what's going on. So hit setup editor, enter. If I go back in, my lists are back. Okay. Cool. Yes, sir.
If I have that data,
Oh, you do stat after that.
if I have some data, if I do the setup editor.
No, it won't. All setup editor does is it brings back, in fact, watch this. If I have data in list 1, 8, 6, 3, and then I go up to list 1 and I delete it, and I have stuff in my other list too, let's say 9, oh, go away, go to. Oh, here's the cool thing. Notice what just happened. I actually didn't mean that, but do you see where the highlighter is? It's on L2. I can't put the number 9 in like the entire list. I have to put the number 9 in a spot. So watch what happened. When I try to put 9 there, look what it said. My data type's wrong. I can't put a 9. I got to put it in a spot. The coolest thing is if you get an error and it has a go-to option, do that because it will put it right on the problem. Right? For example, you notice how there's a minus key and a negative key? When you want a negative number, you got to use this one. When you want to subtract something, you better use that one. If you use the wrong one, it says syntax error. Quit, go to. If you hit go to, it'll put the cursor right on top of the bad sign, the minus or the negative, right? And you go, oh shit, I just got to change that. There's a lot less guesswork when you have the go to option. It doesn't always give you the go to option because sometimes it has no idea what you're trying to do. But so I say go to, it says that's the problem, dude. Oh crap. So everybody heard the question earlier, if I go to that setup editor, does it mess up my data? No. If you go to stat, setup editor, go back in. Even the stuff that was there when I deleted it is still there. Right? Because as a student, you're going to learn this very quickly. Sometimes you're going to get large data sets. And when I say large, I mean at most like 50, not hundreds. That'll get a little crazy. What sucks is if you put one in wrong, or you're doing it, and you accidentally hit delete, and your list goes away. You're like, no, all that time, put the stupid stuff in. So thankfully, the calculator errs on the side of keeping it. You have to actually tell it to clear it for it to go away. You turn it off, turn it back on, your data is still there. Right? So don't freak out about that. Let's get somebody afraid to turn their calculator off. It almost did. Turn it off. There we are. So, let me see if I can manage this. What I want to work on right now is just putting some data in, just to get used to how that works. And then we'll talk about how to create this histogram. So I need to show you the data.
So we're supposed to clear all of the boxes.
Yeah, right now your screen should look just like that. How we doing? If you have stuff in L2 or L3, you can go over there and clear it. Right, so you got a nice blank set of lists to start with. The data we're going to work with going to make work, is it?
Did you have to like walk right under it last time?
Maybe it is just a really weak
Signal? Or laser, whatever.
All right, let me see.
Mine is different. Does yours still work?
You just have to,
This thing's going to mess with me this whole semester. You see how it waited an extra second right there? It's like, all right. All right, so this is an incredibly exciting set of data. This is these are the ages for everybody who actually filled in the survey. Now, can somebody tell me why this isn't necessarily a good sample to work with?
It's just
Has everybody filled in a survey?
no.
The people that did, isn't it sort of a voluntary response now? But not really. I mean, everybody's going to eventually fill it in.
well.
And this is a decent percentage. This is 47, including me now. So it's a decent percentage of the entire population of us. So it's not really that terrible. It should give us a feel for our distribution of ages. I wouldn't expect that the people who didn't do it are going to all be older, all be younger. It's probably a mixture of people. So what I want you to do right now is to put this data into list one.
All of that in one?
Yeah, buddy.
Yeah, but
All 4 rows?
All of this into list one. The only time you would go to list two is if you had a separate set of data. Like if I had ages and heights, and I wanted to kind of analyze them together. You put
Doesn't matter what order?
Do we go down or across?
Doesn't matter at all, because the first thing we're going to do with it is sort it. Right? So while you guys are doing that, I'm going to do it too. All this data. I want all the ages in L1. Cool. Does everybody understand? All the ages in L1. Yeah. Yeah. Histogram, exactly. And actually, I'm not even going to show them how to do it in the calculator. We're going to do it by hand.
When I was in high school 500 years ago, I was like, do you not have an outline? I just... Recently trying to tell all this. Yes, I need do that. Oh, I think that's
Oh, sure.
Did you just do the first 2 days? Yeah.
So to know that you're on the right track, there are 48 pieces of data up there. So when you enter your last piece of data, it goes to the next spot. It should be the 49th spot then. That's the last blank spot, the 49th spot. What really sucks is when you put all this data in and you got 48 of them and you got 47 in the calculator. You're like, oh crap, which one did I miss?
Now, how do you know it's a 11 line?
What's that?
That's what I got it.
You got it? Okay. How we doing? Now when we come to the, well, I'm going to give this away too early. You could put something in, like put a 2 in instead of 21. I doubt there's a 2-year-old in here that's actually enrolled. When you sort your data, those kind of outliers will become very evident, right? You'll see a 2, you're like, well, that can't be a 2. Which one was it supposed to be? That'll suck. So the blank one that you end up at should say 49, right? You left one out somewhere. Yeah, you have to figure out which one you left out. Or you can just hang out, you'll have most of it. You can do everything with us, and then we can figure out which one you left out when we all see how many is in each group. Yep. Okay. So it looks like most of us have it in there. So here's the thing with histograms. I want to make classes because I know that there's a lot of people who are, let's say, what seems to be the most common age?
20.
Right? And the next most common age looks maybe 21. Right? Which makes sense. It kind of agrees with what we think. There are a lot of people coming back to school after they've been in the business, but most of you guys should probably be coming very soon out of high school, right? What sucks, I don't want to give each age its own bar, though, because there's not very many 38-year-olds. Not very many, some of these ages, right? So they're not going to have much to tell me. I want to kind of group these together so I can see where do people seem to be mostly. So the highest bar I see, I'm like, oh, that's where the most people are, right? In that group. So it's making those groups that we're going to focus on right now. That's where we're going to get a lot of math in this. So you guys really don't know me too well. I don't know if you trust me yet, but trust me. I'm going to do something on the side here that's going to explain the math a little better. Let's say I wanted to, I don't like this. I'm going to put up these strips of chalk. I could write on chalk, but it's like comes in strips. You guys with me? I want to like overlay this with panels of chalkboard. Is that cool? And let's say, I didn't bring a thing with me. It's like this is, I don't know what makes sense here. 9 feet across. How are we doing? And I want to use, say it, Jeff. I want to use 6 pieces of chalkboard. You guys see? So I want to put 1, 2, 3, 4, 5, 6. Can anybody tell me how wide does each one have to be to cover the whole thing? Right, so it's 9 feet across. I want to use 6 pieces of board. How are you guys doing that? So the width of each. How'd you do it? Multiplied 6?
9 divided by 6.
9 divided by 6, cool. So 9 divided by 6, because I got 9 feet, and I want to break it up into 6 parts, and it will tell me how wide each one has to be. Does that make physical sense? Cool. Because when I step into doing the same exact thing with data, it loses its physical sense. You're like, what the hell? Why are we dividing those things? What the hell? But that's what we're really going to do. So you get, if you reduce this, right, 3/2, so you get 1.5. So each one's got to be 1.5 feet long to cover this up. So I can use my much preferred chalk that I miss. Okay. So what's it got to do with us, with our data? Can somebody tell me right now what's the highest data point? 56. And what's the lowest data point? 18. So the width of the board that I want to cover is equivalent to the width of the data. How wide is my data set? How wide is my whole data set? What's the range of my data set? I'm going to use the right one.
18.
Range of data. So it goes from what to what? 18 to 56. So how wide is that?
38.
Yeah, because what'd you do? 56 minus 18.
Subtract 18.
Cool, so 38. So it's high minus low. So that's just like the 9 feet. Now we get to pick the number of bars, the number of what's called classes. How are we doing so far? I could have a class of people from 18 to 24, and then a class of 25 to something, and go on from there. We don't want to use like 2 classes and have these 2 giant rectangles. What good would that do me? Do you guys see what I'm saying? If I only pick 2 classes, I'll have 2 giant rectangles. Would that really give me a feel for where people seem to be distributed? No. If I use 30 rectangles, I'll have, there won't be much in each. It'll be a picture like this. It'll be a picture like this with gaps and then gaps and then, what the hell good is that? So normally in this class, I think Trilla says something a little different. We're going to use from 5 to 10 classes, right? We get to pick the number of classes, which is really the number of rectangles, right? Just like on that bar graph. From 5 to 10. If I have a really large data set, how many do you think I want to use? If I have a lot of data, 10. If I have not too much data, 5. So it's not a cut and dry thing. There actually is a formula for it that involves logarithms, but I really never use it. It's not cut and dry. If you have a kind of a small data set, like I'm talking about in the 30s, 40s, 50s of data, I'd use 5 or 6 or 7. If you have hundreds of data points, I'd use 8 or 9 or 10, right? So normally in here we're going to use 5, 6, or 7. We're not going to see those crazy big data sets. What are we doing? Okay. So how many classes do you guys want to use? 5, 6, 7, 8, 9, 10? 7, 6. I like that. 6.5 classes, please. So let's use 6. So we'll use, I want everybody to use the same thing in this case so we all have the same picture at the end. So we all know that we're doing okay. Okay. All right. So let's go back to our data. Let's attempt to go back to our data. So it would have been easier to see this if I would have sorted it earlier, but I just didn't because I didn't want to. What we want to do now is first we'll figure out how wide our classes should be. All right? So let's use the same exact formula we used earlier. What's the width of each class going to be? It's going to be the range, how far we've got to go, divided by the number of classes. Yes, ma'am.
Okay, I'm sorry, but I stopped listening for 2 seconds and I don't know what you're talking about.
Oh, that's a terrible thing. Come on.
Classes. Sorry, it's easy. Just get sidetracked for a couple.
Gotcha. So the classes are really just another name for those rectangles. So a class could be everybody that's 18 to 24.
Oh.
That's the first class. And then 25 to whatever. Yeah.
Okay.
So normally when we hear class, we think class warfare, which is described by everybody who makes this much money is in one class, and this much to this much is another class. It's sort of like that.
Okay, thank you.
Without as much controversy. Yeah. So what is the width of each of our bars going to be so that we can cover this whole data set from 18 years old to 56? What's the range again?
38.
38. And we decided to use 6 classes. So what's 38 divided by 6?
6.3.
6.33 forever. Always round that number up. Unless it comes out to a whole number, in which case you still have a little bit of an issue to be careful about. We'll eventually get to that, but always round that up. Think about it. If I round down, and I've got to be at least this wide to cover the whole data set, and I round down and make them each smaller, will I still cover my whole data set in 6? Will I need like one more class to cover the end? I want 6 classes. So you round up. They each have to be at least this. All right, let's make them that. I always have a few students that keep it 6.33. They make it 6.34 maybe. I'm like, good God, don't do that to yourself. Make it a nice whole number, or at least 6.5 or something halfway. That's easier to work with, right? Okay. So now we're going to make what's called our frequency distribution. And a lot of the words in chapter 2 they sound a lot worse than they really are. This is just, I'm going to write my classes and just tally how much is in each class. Just keep track of how many I've got in each class. Okay. there are two ways to do the classes. I'm going to show you the book way first. And then I'm going to show you the way that I was taught second, the way that I personally do it, because it's better. But either way, if you want to do the book way, that's cool. If you want to do the other way, it's cool. The first class, where should I start with the first class, obviously? 18. Now here's where it gets freaky. Where should the next, so it's 18 to something, right? Don't tell me what yet, because it's not going to probably be right, because it's a little freaky. Where should the next class start if my class width is supposed to be 7? The next class should start at what age? 25. You guys can see that? If my classes are 7 apart, the next class should start at 25.
This means 6 added up for this class, right?
Say again?
And then you have to add it up from the 6 from this class, right? Like 8 plus 6 and then
Yeah, so keep adding 7, right? And then here it should be 6 across, right? And I don't want to put, why don't I want to put 25 here also? Because where would the 25-year-old go? In both classes? Which class would he go in? So this has got to be what? 24.
0.5?
It's got to be 24. Why? Because I can't have 25 in 2 different classes. He's got to go in one spot. I can't double count anybody. Okay, stay with me now. I know there's a little bit of specifics with this way of doing it. So now the nice thing is once you get these set up, you just keep adding the width. 24, this has got to be plus 7.
31.
31. I hate the way they put this. Okay. This has got to be 32 to 38, and then 39 to 45, and then 46 to 52. And so far I've got 1, 2, 3, 4, 5. And of course 6 is how many we wanted. So if I do one more, 53 to 59, I catch everybody, right? Mm-hmm. Okay, cool.
excuse me, 32 to 38. You are adding 7?
I'm adding 7 here, 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 and here, here. Now the thing that really gets us freaked out is, and I understand this, I see a lot of you guys are like, what the hell? That this is 6. But think about this. If I want to go to graph this, I want this to be my ages. So I'd be 18 and then 24, 25. There'd be like a gap. So I make my bars, and somebody looking at this would say, it looks like you skipped people. There's gaps. There should be no gaps in between your rectangles. So, these are what is known as the class limits. The class boundaries is you go up and down by a half, so you end up with no gaps in between the rectangles. So like the class boundaries here would be 17 and a half to 24 and a half. And then this would go down to 24 and a half. So you see how these would fall around on top of each other now? Without double counting anybody? So how wide is this first class really? 18 to 24 is just the limits. The boundaries are here. How wide is this? How far apart are these? 7. So your width is kind of hidden. That's why I always say do this one and then add 7, and then this one's 1 down from there, and then go from there. That'll keep you straight. This will always be 1 less than your width. And that's why. All right, yes, sir.
Jeff, where do you put 17 and a half?
There is no 17. So obviously I could have started at anything I wanted to as long as at most it was 18. I got to be able to catch that first person. If there would have been a 17-year-old, we would have started at 17.
No, I mean 17 and a half. You're saying, so there are no gaps in it.
Did our data have any decimals in it?
No.
No. So your question about like where would 24 and a half go? There was nobody that called themselves 24 and a half years old.
But there's maybe a gap when we put it in an Excel, for example.
This first bar, now this first bar would go 8 17.5 to 24.5, right? That's the first class. Where does the next class start? 24.5, so now there's no gaps.
Oh, I see.
Yeah, cool. So it doesn't look like you skipped anybody.
So I actually put 17.5 when I want to graph it.
When you graph it, exactly. Cool. I love it. So use those boundaries when you graph it. Okay. Are we semi-decent with that? There's a few things to get used to there. You see why they've got to do some of the stuff that they do. It's because the way they chose to make their classes. So the way I'm going to show you next is not going to have any of this limit and boundary crap. All right, so if you like that way better, cool. But this way I think more students like because the book actually has examples like this. So these are my classes. Now we just want to start counting up how many is in each class to make our frequencies. Yeah.
After that, it says from the data, what's the people is. This guy 18 and talking in between the inside the phone, right?
Yeah, I want to count up how many are between 18 and 24. So of course what I want to do right now that we haven't done yet, let's see if we can do it without turning him over. What do we want to do with this data to help us fill this in? Sort it.
Wait, why do you got 49?
Again, because here's the 48th one, so of course the blank one next would be 49.
Oh, okay.
But your last data point should be in the 48th spot.
Okay, so
If it's
why
not,
is-
you left somebody out. Okay.
No, I messed up. I don't know what I did wrong.
All right, so we'll catch it as we go, but still do what I'm about to do. If somebody else is in the same boat as you, we'll catch which number you missed here in a minute.
No, I did miss one. I mean, I got to 38, but then I did the arrow, and instead of going to the next one, it gave me this.
Oh, because you're up here at L1. Okay. So now you're at the bottom. So you did skip somebody because that's the 47th spot. So you are missing one. But still do what we're about to do. Still do what we're about to do.
Okay.
So I really want to be honest about that right up front and want you to realize this is inherent in data analysis. In fact, have you guys ever gotten the little notices about make money working from home? And a lot of times it's data entry crap. Nobody wants to do it because part of it is checking your work to make sure you didn't miss anything. Sitting there all day, 47.8, 53.8. God, can't pay me enough money. Believe me. The funny thing as I say that is I would sit all day and enter data as long as I was able to then analyze it, because that's where it gets interesting. This is part of the work. So now let's sort the stuff in list one. So go to stat. What do you think is the difference between these two, A and D? Sort. Sort A, sort D. Yeah, sort ascending means from lowest to highest. Sort descending. We're going to just sort ascending to go along with this, right? So sort ascending. So go to number 2. You can either scroll down to it and hit enter, or you just hit the number 2. Now see how it's kind of waiting for you to tell it something? Sort what? Yeah, which one did we put the data in? List 1. See where list 1 is?
Yeah.
For those of you who have not used this very much, it might be yellow on your calculators, but how do I get to that L1?
Second one.
Yeah, that's like my shift button here, right? Hit second 1. Someday I'll actually be able to do this up together. Second 1, and that'll be L1. So hit second 1. So now look what I'm telling you to do. Sort list 1. You can close that parenthesis or not, I don't care. It doesn't care either. Now if you hit enter right now, it just says done. It's a little anticlimactic. Is everybody with me on this? You I desperately need you to tell me if I leave you behind, right? It's always weird doing technology with a group of people. Everybody's got weird things going on. Go back to your list, and of course, it should be in order, thank God. All right? Okay. Oh, sorry. So hit stat, edit. All right? So when I say go back to your list, stat, edit. That's how I get back into my list. Okay, so is everybody sorted? So how many do I have in the first group then? I want to count from 18 all the way up to the age 24. Let's see, 1. first one's kind of nice because if you just put your thing on the last 24, it'll tell you right there. 29 of them, right? How we all doing? You good? Have we figured out what was missing maybe? No? What's up?
I don't know.
Oh, you didn't sort it yet.
No, I did. I did.
So
I
go to
did
stat.
everything. And I went to
Sort.
2.
Mm-hmm.
And
Oh, I see. You just didn't hit enter. So once you tell it this, hit enter so it'll do it. Cool. Now go back to your list. Stats. Edit.
Edit.
See, now it's in order. So now you can count 18 all the way down to 24. Everybody doing all right?
Can we get 28 so okay? Not 29. Whatever.
Did you have all the data there in the first place? Like, does your list go all the way down to? Then you might have input one incorrectly, right? Because I'm pretty sure it's 29. Yep.
I came up with 28.
I got my little cheat sheet of. I did this before the class. Yeah. Yeah, see, yeah, you gotta, it'll assume a lot of things if you don't tell enough information about exactly how to create it. So it might not have done your classes the way you really wanted it to. No, keep going, just keep going. 25 to 31, I'm sure some of you guys have already kept going. Yeah, it looks like 11, right? And then 32 to 38. Looks to be 6. Is that matching up? What's up?
No, I'm not following. What's the?
All I'm doing is, I just count. How many are aged 25 to 31? I counted, and there were 11 of them. How many are aged 32 to 38? So see how I stopped? There's 38. So I counted between there, and that was 6. So now 39 to 45, there's 1. How about 46 to 52?
0.
Nobody. And then 53 to 59? 1. Cool. Is that what you expect for a typical class on campus? Of course you would, right? Because more people should be coming in. We do have people on this end, and some classes might have more on this end just because of what they are, retraining or further certification for your job. You'll have more older people in there. But this is what I expect for like a Math 160. I expect more down this way, right? Now, if I just give you pure numbers, as human beings, we really don't like that too much. What really helps us out better is something relative, right? If I tell you, for example, I've seen studies like this that people took seriously. They say, oh man, there are so many people in California that are on welfare. There's more people in California on welfare than in Vermont. That's not fair. There's more freaking people in California. So you really want to talk about what to compare the two states.
Population.
What about, but you want to take it into account, but you want to, instead of saying the number of people on welfare in California and Vermont is this, the percentage of people in California and Vermont, because that's relative to the population, right? I keep saying that word relative because that's what we call it. We call it relative frequency. Another name for relative frequency, percentage. So how do you get the relative frequency for this then? Yeah, I would take 29 divided by what? The total, which was 48. So this would be 29 over 48. And make that into a percentage. Obviously the biggest cut was there. 60. Yeah, just make it a percentage. Cool. And then 11 out of 48. 23%. Is everybody getting those? Do you see where those are coming from? You get 0.23 to make it 23% maybe. 6 out of 48. Yeah, 12.5%, right?
Like in each grade.
1 out of 48.
No, I know, but
1.92%. Yes, sir.
48's number of ages, right?
Yeah, sorry, yeah. 48 was the size, was all the people. So you could say to me, how many people were aged 18 to 24? 29 people out of 48. So exactly the way you say it is the way you work it. 29 divided by 48. That's the relative frequency, the percentage.
The second one.
You missed one.
6 over.
11 of 48.
11 over 48 is 23%.
Yeah.
Cool. 6 out of 48, 12 and a half. 1 out of 48, 2%. Zeros, you can calculate 0%. And finally, 2% at the bottom. You guys can't see that, but it's another 1, so it's 2%, right? Okay. I'm desperately trying to leave us enough time for you guys to do it on your own.
So that was that your way?
No. Real quick word on my way. My way, instead of having 18 to 24, 25 to 31, this is the book. This isn't really my way. It's the way I was taught. I didn't create this.
Well, that's what I mean.
So I will call it just my way with them. My way would say 18 to 25. 25 to 31. Now you can see why people would be turned off by that. If algebra gave you any trouble, you don't want to be reminded of it too often, right? But what does this really say? All the numbers that are between 18 and 25. But which one does 25 go into? Because that's including 25, right? See, so there's no worries about, what about somebody who says they're 24.9 years old, some little dork? Well, he goes there. There's no ambiguity there, right?
Right.
There's no limits and boundaries. Limits and boundaries are the same thing. When I go to make this, it'll be 18, 25, 31. They already kind of line up. So if you like that way, I'm cool with that. Do it that way. There are questions that give you problems that are like this that you have to interpret limits and boundaries. You still have to know those definitions. But to make your own histograms, you could do it this way or that way. I don't care. Okay, maybe. So, last step is to actually create this histogram. And before I get too far, everything we just did, that's section 2.2. The crappy thing, the thing you want to keep in mind, do not do section 2.2 and turn it in and then start 2.3 because 2.3 refers to what you did in 2.2. You guys with me? 2.2 is set this up. 2.3 is go make the histogram based on what you just did. So you don't want me with your data and you're at home trying to do 2.3. You have to do all the work again. You don't know to do that. So do 2.2 and 2.3 together and turn them both in at the same time. It's a good idea. Okay. So where do I want this to start? These are the ages.
18.
Careful.
7.5.
17.5. I love it. Because we're going to do it the book way, really, up on the board. If you want to do the other way, it would be 18. And then you just have, and then how far apart are the classes again? 7. Isn't the class with 7?
Yes.
This class should be 7 away from the next one, so you just keep adding 7. So 24.5, 31.5, 38.5, 45.5, 52.5, 59.5. And we catch that N there, right? So that's a really nice thing. The minute you know the first one's just half down below the very first number, the very first limit. Now you just add your width, and that'll get you all the way through it. This one, let's do relative frequency here. I could do frequency or relative frequency. Let's do relative frequency. Here's the bad part. I always get somebody do this. They'll say, what do I got over there? 12, 20, 60. Yay! Scales way the hell off. Thank you. So the quickest way to make a math teacher go insane with rage is to do this. Your scale has got to be consistent. So I need to be able to go from 0 to 60 in 5 seconds. No, it's 0 to 60. So what kind of scale maybe I want to use?
10, 20, 30.
Tens maybe. So 10, 20, 30. Wait, did I give myself enough room? No. Be aware of your paper.
15.
Tens is good. 10, 20. Jeff, hello. 30, 40, 50, 60. Hopefully yours is a little neater than mine. And yes, if you want to get like grid paper or whatever, especially if you're really messy or whatever, great. I love it. So how tall should this first bar be?
The top is always
Yeah, it's got to be the top. So 60. Pop. Now coming right after that bar, this one goes up to 23. So here's about 23 right there. Whoa, I went too far, sorry. Yeah, be really neat there, but nowhere else, Joe. Then the next class, I mean, now it's pretty simple. Once you made that table, the picture's not that bad. The scale normally gives some people some trouble. That bar will be 12.5, right? So maybe about right there. And then this is the one that's going to be a little difficult. 2, 0, 2, right? Okay, cool. All right, there you go. So now that's a really nice visual of the distribution of ages. So I can make this for every classroom on campus and very quickly see if I see another one that's got this. I'm like, what class is that? That's not where I would expect it to be. It must be some kind of like recertification for job training or something where it would draw more people who are older to it, right? And not really too many young people would be in that situation yet to do it. Okay, cool. So, here's what I want you guys to do in the tiny little bit of time I left us to this. Working together, if you want, and I've stepped it out for you in this, I want you to analyze the heights that I got from you guys. Oh, shoot.
Keep the fire on.
Should we clear list 1 before we put in?
Oh, yeah. So go ahead and clear list 1.
Are you gonna give us a practice quiz thing? Or no?
Yeah, I always give practice tests. Never practice quizzes, though. Quizzes are always very basic things.
Hey, clear again. I've got highlighted.
Go to L1, yeah, and then hit clear, enter.
You just keep going all the way up until highway to 1.
Oh.
Then you press clear enter.
Thank you.
Yeah. Lecture, you think now. It should be out by now, yeah.
To delete this list, what do you do? The whole list?
To delete the list, let me get that up there. Just go highlight the list name, hit clear, enter. Cool. There's also, if you hit stat, there's a clear lists option where you can hit clear list and then enter L1, comma, L2. That's why you guys have a comma on your calculator, by the way. Not normal to see too much punctuation on a calculator, but that's why. So call me over if you're having any trouble. Oh, I just put it, what should it be? 2, 3. Okay, so I just hit 4 instead of 7. That's my bad.
I just started on 57, but I just wanted to make sure.
Yeah, you're fine. Yeah, yeah.
Should we add in the 6 anyways? And
Ah, good. So you guys picking up on something yet? No, I didn't alter any data. It's the way it was given to me. Somebody told me they're 1,080 months old, which is interesting.
So do we keep the 6
It's
in
pretty
there?
old. What do you guys think about that 6? I'm trying to get you to be true statisticians. Do you keep it in there?
No.
Hell no. This is a situation. Not every situation is easy to spot outliers, but I really doubt. The data is students in my class.